So x is 7 root 2 and y is 7 root 6. We know that we get 7 root 2 from cutting the hypotenuse in half because the shortest leg is always half of the hypotenuse. How do you get the side across from 60? Well, you do x, this is x, root 3. You do x root 3. Well, root 2 times root 3 ends up as root 6. So y is 7 root 6 and x is 7 root 2. You need to know how to work with radicals to be successful on this. Okay. A rectangle has length of 4 root 2 and a width of 2 root 3. Find the length of the diagonal. We will always want to keep our answers as a simplified radical unless it's a whole number. So the answer to this one was 2 square root 11. You may or may not have drawn a picture. If you did draw a picture, you have a rectangle. You know that the length is 4 root 2 and the width is 2 root 3, and you need to find the diagonal. We definitely have a right triangle here. We definitely have a right triangle. And we don't know the angles. I don't know if it's 45, 45, 90. I don't know if it's 30, 60, 90. It's actually neither of those. So when it's neither, then we need to employ good old Pythagorean theorem. One thing that people forget to do, oh, my equal sign had 3 slashes. Awesome. One thing that people forget to do is they forget to square both of the parts. Square the 2 and square the root 3. Square the 4 and square the root 2. Okay? So what would we have? 4 times 3, this would be 12. 16 times 2, right? 32. Am I doing okay? 44 equals x squared. And then you factor tree the 44 and you get 2 root 11. This one, it can't get any more straightforward. This one follows the pattern perfectly. 8, 8, 8 root 2. How did I know it was 45, 45, 90 if none of the angles are labeled? Yes, it was, Johan. Because it's right and it's isosceles. If it's right and it's isosceles, the angles have no choice but to be 45 and 45. Very good. Okay, so 9 is off the table. There are tick marks on each side of this triangle, so I wanted to make sure that you saw that. And you're solving for the value of x. Make sure you keep it as a simplified radical. This is important because we do need to know the fact that if a triangle is equilateral, all of its angles are 60. Because 180 divided by 3 is 60. Now this angle up here was bisected, so we know that that one is 30 and 30. We now have ourselves a nice, beautiful 30, 60, 90 triangle. We know that the short leg is half of the hypotenuse, and we know that the long leg is the short leg root 3. 6 root 3. And so x is 6 root 3. If you need to make your little chart, you can make your chart. Here is the trivia. Solve for x, keep your answer in simplified radical form. 209. X is the square root of 209. That actually cannot be simplified. That is in simplest form. Okay? Good job. So the important thing is to know, first of all, that you're doing Pythagorean theorem. The second important thing is to not do 15 squared minus 8 squared, because that triangle is not a right triangle. But when you draw the altitude, this triangle is a right triangle. So you do Pythagorean theorem, 15 squared minus 4 squared, and you take the square root. You cannot factor tree it. Right, 209 is not prime, but its factors are prime. There are no perfect squares in 209. Okay, you're solving for x and for y. Make sure you put what each of them equals separately. All right, so in this problem, we have multiple 30, 60, 90 triangles. And this one right here, the 12 is across from 90. So we know that this is 6, and we know that this is 6 root 3. We can drag this over to this triangle. We know that this is 6 root 3 as well. That one's across from 30, so we need to be careful. To get across from 90, we simply double it. And to get across from 60, we know it's x root 3. X root 3. Well, square root 3 times square root 3 is just 3. And so x is 18 and y is 12 root 3. If you have trouble with that, remember to go to the side and make that little chart and put the values in the chart where they go. Solve for x and y. Make sure you're really careful on this one. Good job. Very nice. So x is 3 root 3 and y is 6 root 3. This is one that if a student was struggling, they would definitely need to do the chart because this one's weird. 9 is across from 60. 9 goes here. The only way to undo multiplying by root 3 is to divide by root 3. So you would need to divide this one by root 3, and then you would need to rationalize the denominator. 9 root 3 over 3. The 9 and the 3 cancel and just make 3. So this is 3 root 3. And goodness, once you know what x is, then the hypotenuse is easy to find. You just double it. 3 doubled is 6. So good job, plus 10 for you. I'm not going to work this one. X is 7 root 7 and y is 7 root 14. X root 2.